Okay, so what we are recording is an example of how to find the equation of the line in a correlation situation, also known as the regression line, using the Meyer line method. So there are 4 methods for finding the equation of the line. The student has to know all 4 because some of the questions will demand that you use this method, use that method, but most of the marks are for situations where you just decide which method you like best when you use it. I have met students who chose Meyer line as their favorite method and used it several times in the exam. But there are also students who only use it once in one of the small questions when they are forced to. Where's my chalk? Okay, so the first thing that you would do if this was a big question, given a table of values, is you would graph it. But if you're doing one of the small questions where they're asking you to use Meyer line, you just need to be able to find the equation. So we're not going to bother graphing this. How do we do Meyer line? It's a weird little thing that involves the mean. Now, mean is meant to be prior knowledge. It's meant to be something you already know about because theoretically in the level 3 statistics you did mean, and even in the level 1 statistics you did mean. Mean is just another word for the average. Students are usually quite good at finding the average of some numbers. So what we're going to do is we're going to Meyer line. We're going to take our table of values and we're going to split it into 2 smaller tables of values. We're going to put the smallest number of points in one table and the larger number of points in the other. So basically we're splitting it in half roughly in the middle. Now it's very important that the 2 small tables you make have to be equal in size, because this process will affect the 2 points that you use to find the equation of the line later in the process. So we want them to be the same size. Well, if I had an even number of points, that's easy. If there were 10 points, I would put 5 of them in the first table and 5 of them in the second. What do you do, though, if there is an odd number of points? It's just a cute little trick, and it's something I have to make sure the student knows. What we do is we'll put we have 9 points here. We're going to put the first 5 points in the first table. So let me quickly do that. 2, 7, 3, 8, 3, 10, 4, 10, and 4, 11. How do I get the remaining 4 points into this table and have it the same size? What I do is I take that middle point and I use it again. So the 4, 11, which we already used, we're using again up here. That's all. Now I'm putting the bottom 4 points with it. 5, 14, 6, 14, 7, 16, and 8, 20. We have managed to create 2 tables of values that have 5 points each by reusing the middle point. It's that easy. Now, to find the average, I'm not going to show all the steps because I think students are usually pretty good at finding averages, so I'll sort of do it in my head, and I think you'll be able to follow along. I'll start with the second table just because I know the answers are easier. 4 plus 5 plus 6 plus 7 plus 8 is 10, 15, it's 40. 40 divided by 5 is 8. Let me double check, make sure I didn't make a mistake. 20, oh, it's 30. 30 divided by 5 is 6. So x bar 2, meaning the average of the x's in the second table, that's the 2, is equal to 6. So you have 5 numbers add up to 30. 30 divided by 5 is 6. Okay, we're doing the same thing here. 10, 20, 30, 40, 50, 60, 75. It just happens to be a multiple of 5. That was just luck. 75 divided by 5 is 15. That means y bar 2 is equal to 15. We have a point. The point is going to have an x of 6 and a y of 15. It's really that easy. It's just a cute little trick. Now we're doing the same thing over here. It's just that the totals are not multiples of 5, so we'll get some decimals in our answer. 2 plus 3 is 5, plus 3 is 8, plus 4 is 12, plus 4 is 16. 16 divided by 5, x bar 1, 16 divided by 5 is 3.2. 7 plus 8 is 15, plus 10 is 25, plus 10 is 35, plus 11 is 46. 46 divided by 5 is 9.2. Y bar 2 is equal to 9.2. That means my first point has an x of 3.2 and a y of 9.2. And at this point, things from now on are going to start looking rather familiar. The students have been practicing finding the equation of a line when you need to know 2 points. We're using these 2 points. So in the slope formula, y2 minus y1 is 15 minus 9.2. x2 minus x1 is 6 minus 3.2. 15 minus 9.2 is 5.8. 6 minus 3.2 is 2.8. And I can get a calculator if I want to simplify this. We can give the answer in the form of a fraction or a decimal. If it's in a decimal, you might have to do some rounding, but that's okay. So 5.8 divided by 2.8. 2.07, it goes on, but I'm going to round it to 2.07. What do we do next? We take our y equals ax plus b equation. We replace the a with 2.07. And then we take one of our points and we replace the x and the y with the coordinates at that point. So I'm going to avoid the decimals and use the 6, 15. 15 equals 2.07 times 6 plus b. Now, 2.07 times 6 will give an answer, but the 2.07 was rounded. I still have the unrounded perfect answer, well, perfect division answer in my calculator, so I'm going to use that instead. So I'm taking that and multiplying it by 6. And I'm getting 12.42, and it's going on and on. So I'll round to the hundredth again. I'll call it 12.43. 15 equals 12.43 plus b. Therefore, b is equal to 15 minus 12.3, which is going to be 2.57. Does that fit into the video? Just barely, kind of. See if I can actually adjust this during the recording of the video. Wow, technology. Okay, so b is 2.57. I'm going to make sure because I'm doing calculations in my head, but yeah, it's good. Okay, so therefore my equation is y equals 2.07x. Oops. Need more chalk. Plus 2.57. Did that fit? No. Okay, I will write it again, and I'll just write it a little bit smaller. Y equals 2.07 x plus 2.57. How's that? Yeah, that fit. Okay, so I found the equation in a straight line. It's the third time I've done that today. It is getting boringly repetitive, but that's good. When the student is saying, okay, this process is boring, it's because the student knows the process really well, and they don't need as much repetition. But any student should do this so many times that they're extremely good at it and feel very comfortable with it, because you get to use it so many times in so many different ways in the exam for this course, and they keep on giving you marks every time. So it's work that is really well worth it. That is Meyer line. The key thing about Meyer line is we're doing the same old thing with the slope formula, etc., to find an equation. But what points are we using? We're using points that are made from the means of the x's and the y's. In order to end up with 2 points, we have to divide the table into 2 pieces, and then we make sure those 2 pieces are the same size. So if there is an odd number of points, the middle point gets used twice. If a student remembers all that, then they're able to do this on the exam. In the small question that asks for it, which not every version of the exam necessarily has a small question demanding that you use Meyer line, but if it does, you just do this method, and it's very quick 5 marks. In the big questions where you need linear equations, which might happen several times, you have a choice as to whether you use Meyer line to find the equation. But if you like using Meyer line, you go ahead and you use it. It's just as good as the other methods. That is Meyer line, and that is the end of this recording. So let me stop the recording. It's asking me if I'm sure.